Student, welcome you all. So today's topic is wave particle duality, uncertainty principle. So in this, we will discuss more about the particle and wave nature of light and how does we can explain it and what about the uncertainty principle. So here, if you see the overview of the topic, here we will discuss like evidence for wave nature of light and evidence for particle nature of light, and then we will come to discuss the main topic of the day, wave particle duality and uncertainty principle. So here evidence for wave nature of light, there are certain explanation is for that, and also there is also some evidences is for particle nature of light. So here, before going to the evidences for wave nature of light, there are the different experiment like diffraction and interference. And once you are talking about the evidence for particle nature of light, so in this case there are the example for this is photoelectric effect and Compton effect. So since light exhibit diffraction and interference phenomenon that are only explainable in terms of wave properties. So these two evidences shows the light is having wave-like nature, and electric effects and Compton effects, they support the evidence for particle nature of light. So light is always detected as a packets like photons. If you look, we knew half a photon or number of photons proportional to the energy density with respect to that. So here if you see evidences for photoelectric effect or Compton effect. So photoelectric effects occur in bound electron, while Compton effects occurs in free electron. In photoelectron effect, the photo and hence the energy of the photon is absorbed by electron, while in Compton effect photon is scattered. So by this way there are different example for explaining the evidence of particle nature of light as well as the wave nature of light. So since there are different evidences for that, that's why this is known as dual characteristics behavior for that. So if you see wave-like of nature, then again you can see uh, we already see here there is like a fringe and maxima. So here, if as you know, the diffraction is the result of light propagation from a distant part of the same wavefront, while interference is the result of the interaction of light coming from two separate wavefronts. Like here there are fringes and maxima. So if it is coming from the different or separate wavefront, the width of the fringes in case of diffraction is not equal, while the fringes width in case of interference is equal. So in case of fringes, in case of interference, these fringes will be equal, but in case of diffraction this will be different. So these are the space which you are looking, and these are the maxima. From this image you can see it in a very easy way. So now it is in a very simplified way. Light comes in a discrete unit which is generally called energy packets, or photon. So with particle property, energy and momentum having both, that are related to the wave like properties of and frequency and wavelength. So in 1923, de Broglie postulated that ordinary matter can have wave-like properties with the wavelength lambda related to momentum in the same way as for light. So here you all might be aware of that the de Broglie relations or de Broglie relationship. Once you see here, so this is lambda equal to h upon P. So this lambda represents de Broglie wavelength. So here you all know, because this is the Planck's constant and this is the momentum. And once if you simplify this can be mass into, all know, equal to mb, velocity. So here if you see the relationship among them, so this can be further extended. So Einstein, in 1905, he suggested that light has a dual character, as we wave and also as a particles. So as we already seen from the previous and the earlier, the philosopher as well as their philosophy, and as per far as the scientists, those who did number of different kind of experiment which relates with the wavelike as well as the particle nature of the light. So the French physicist Louis de Broglie in 1892 or 1987, he proposed that matter also has a dual character, as wave and as a particle. The de Broglie was awarded uh, 1929 a Nobel Prize in Physics. So due to, because he had gives the more reliable explanation, or the experimental results for to explain the wave and particle nature of light. In Bohr theory, electron is treated as a particle, but de Broglie theory suggested that matter and therefore electron also has a dual nature or dual character. Here the meaning dual, as we already discussed, particle as well as wave-like of nature. So both has a material, particle and wave. He derived an expression for calculating the wavelength. From his expression you will be able to calculate how to calculate the wavelength. So for of a particle of mass m moving with velocity u, according to which lambda equal to h upon mu. So if you see again, you can simplify it. The de Broglie equation can be easily derived by using the Einstein mass energy relationship. So this is a very simple equation which you all might be aware of, that since energy is having with respect to mass and velocity of light, so there is a relation equal to mc square. So here equating this energy equation with the energy of a photon associated with frequency, we have h nu equal to mc square. So nu equal to c upon lambda. These all are very basic terms and very basic relationships. So all students might know this. So these relationships, once you will correlate these relationships, just incorporate and manipulate here. So you will see hc upon lambda will be mc square. So if you see the lambda, so the final form which it will becomes, like here from c to c, this will be nullified, this will be replaced. So here lambda will be h upon mc. So replacing this c by the velocity of electron, or you can represent it like u. So we will have a relationship lambda equal to h upon mu. So this is in very simplest form, lambda equal to h upon p, and this p is represents the linear momentum of the particles. So this is a very important relationship which has been given. So this equation helps to calculate the wavelength. So de Broglie, for this job or for this work, he was awarded the Nobel Prize also to explain the wave and particle nature of light. So that is having a very great relevance for explaining many more characteristics, properties by different matters and different like waves and all, is helpful to ascertain their characteristics features. So now coming to the another topics under this lecture, Heisenberg uncertainty principle. So all you might have be aware of this, during your undergraduate, because this is also being studied there also. So here you can see the Heisenberg uncertainty principle. This is like, as the name is saying, uncertainty. So it means there is what type of uncertainty we are talking, like, so here, like position and momentum. So what is this? We will go in detail. So use light with short wavelength, accurate measurement of position but not momentum. Means there is uncertainty to find out exactly the position and momentum. So that is why this is called uncertainty principle. So with light, in case of light with short wavelength, so accurate measurement of position can be possible, but you cannot measure the momentum, or P, which is represented by the P in case of uncertainty in momentum. So this is a small, delta P and delta X represent the change in us uncertainty in terms of, if you are talking X, that is represented here is position, and this P is momentum, and h is, as usual, this is in a constant, Planck's constant. So in another condition, use light with long wavelength. When you will use the light in short wavelength, then you can calculate, or you can accurate the measurement of position correctly, but not the momentum. But at a longer wavelength, you can check once, you can find out accurate measurement of momentum but not the position. So this is the uncertainty with respect to the one particular parameter. So the more accurately the position, the small, that is represented like delta X, is very small. Accurately, the more accurately you know the position, the less accurately you know the momentum, and vice versa. Means at once, if suppose you can measure this particular parameters accurately, but in that case, uh, but if you change, the light is having the longer wavelength region, then you cannot be accurately, you can measure the position of that. So this is having uncertainty, in either position or momentum with respect to the wavelength of light. This is vice versa in case of either position or either in momentum. So that is why this is named as uncertainty principle, or uncertain, the measurement can is there. So it is impossible to know both the position and momentum exactly. So it means in a wave, or like in a light wave, there is very difficult uh, to measure the both, either position and momentum exactly at the same time. So here delta X will be 0, suppose that is, and delta P, which is momentum, is 0. Here the uncertainties delta X and delta P are inherent in the physical world, and to do with not with the skill of the observer. And h is very small, it is the power of 10 raised to the power minus 34. So these uncertainty are not observable in everyday life. So now you all know this is the very simplest relationship with respect to energy and time. So we have to replace, like here, that position and momentum terms with energy and time. So this is having h upon 4 pi relation. So the more accurately we know the energy of a body, the less accurately we know how long it possesses that in energy. It means once, if suppose accurately you will be able to measure the energy, but same time you will be less accurately, you will be able to find out the time, how much that energy is possessed by that particular wave, if you are discussing about to explain that. So similarly, this will be the vice versa. If the energy can be known with perfect precision, then only if the measurement is made over an infinite period of time. So this is also, there is an uncertainty in terms of both the parameters. So that is why in terms of energy and time, this is also called Heisenberg uncertainty principle. So you all know there is simple, there are examples, which is like suppose there is some of the example, calculate the de Broglie wavelength, because from the above what we had discussed so far, on the basis of that, there are a number of problems which is related to the direct relationship among the there is lambda, like de Broglie equation, that is h upon mu. So here, in joule second, you all might be aware of that. The Planck's constant, here the mass, if suppose it is like asked for the electron, so the mass of electron, that is approx 9.12 into 10 is to the power minus 31 kilogram. And velocity, you has been given here, moving with particular velocity is being given, so that you have to put on this equation. So finally you will get the answer lambda in a meter, and you can convert it in centimeter and other units as per the requirement. So here the similar way, if you want to check the Heisenberg uncertainty principle, so there is one more example for that as well. So like in a cricket ball, which is having the weight like 100 gram, is to be located with zero point 0.1 angstrom. So what is the uncertainty? It is velocity, and you have to comment on this. So here you also know this is like position and momentum relationship as per the Heisenberg uncertainty principle. So you have to use the uncertainty principles, Heisenberg uncertainty principle, and then you have to put the value which is given here, and you have to keep in mind if you are converting the unit, because that conversion is very important. So here the grams you have to convert into the kilogram, and then your readings, you have to put the joule per second your value with respect to Planck's constant. So the major points which has to be kept in mind once you are calculating such kind of problems, because these numerical problems is quite easy, but the only the mistakes which has been generally seen is to the unit conversion. So this is to be kept in mind once you are converting certain values. So you all need to change the particular unit and then to calculate, and finally once you will calculate, your answer will be quite correct answer you will go. In here, so that there is some uncertainty, and the comparing this value with the typical velocity of the cricket ball, we find that this uncertainty velocity is very negligible, because this is the uncertainty in velocity, because you are calculating this. So what is the comment on your result means what you expect from by the answering this question. So actually this is the uncertainty which is like in 10 raised to the power minus 22 meter per second. So obviously this is a very negligible value. So this is having very negligible uncertainty in their velocity. So as per the uncertainty principle, so this can be calculated with the help of Heisenberg uncertainty principle. So by this way, however, there is uncertainty, but this is quite negligible. So by this type of question, there are many more problems which you all needs to practice and to solve. So from the overall discussion, we discuss about the wave particle duality and uncertainty principle. So in wave particle duality, we had seen that the light is having both the properties like wave and particle nature. So that was also we had seen from the various experimental study was carried out by various scientists like the Isaac Newton, he has said the light is having, you know, particle kind of nature, and those small particles, he said that them like corpuscles, but that was not fit all the, nature, like interference and photoelectric effects, diffraction. So these phenomenon was not explained by the particle kind of nature of the light. So the further they are having some, wave kind of nature, like in case of diffraction and interference. So further, many experiment which explain the wave kind of nature of the light. So this is quite uncertain, or it is to say whether the light is having particle kind of nature or light is having either wave kind of nature. So that is the basis for duality, of the principle of duality, because the dual nature of light, because of some of the explanation which helps to due to the particle nature of light, and some is. So in the latter state in 20th century, the many more scientists, they had extended the work, and they said the light is having a, uh, in a form of quanta, which is they had called energy packets, comes in a form of energy packets, or light emits in a form of either absorbed or emits from the object is in the form of energy packets. So those energy packets were after the Planck's theory, if you know, those is called as in the form of h nu. So that is a quanta, and that is having various forms, which is depends upon the matter to matter, and they released either absorbed or either emit in a form of quantum. And also we discuss about the uncertainty principle, because we cannot uh, you know ascertain the position or the momentum, or in terms of energy and time, with accurately, because there is always certain uncertainty is there. It means if suppose you are able to find out accurately the position, but at the same time there will be certain kind of uncertainty in their momentum. So similarly in case of energy and time, so we also discussed that some of the examples we also seen here, about the Broglie, de Broglie and Heisenberg uncertainty principle. So this all we had done. How can these equation can be helpful to calculate the small problems, and to see the uncertainty in case of the numerical problems. So how can we calculate them? So here, out of the overall study or overall conclusion, today's discussion, or in this lecture, we learn how the wave particle duality can be explained, how we can explain the uncertainty principle, and how these principle can be helpful to calculate the problems if we had certain values. So here the major question which is being formed, or which can be asked, like explain the wave particle duality with suitable justification, discuss the Heisenberg uncertainty principle and the associated experiment, you can justify your answer, and here you can give one or more examples as we discuss, and apart from that you can take many more examples related to which explain the particle nature, and which examples which explain the wave nature of light. Similarly, you can see with the help of example, you can explain the uncertainty principle by assuming some data, and then you can see, like in case of the example we discuss here. So many more example is there by which you can see And then here there are number of references, reference materials, reference books from where you can see uh, to get more information about such kind of experiments and their theories in more details. You can refer the many books is there. So textbook as well as reference book you can see. So overall discussion you can refer, textbook even you can refer. You will get many more idea on the subjects in more depth knowledge. So all is I thanks for all watching this video and listening this video lecture. Thank you so much.